Okay, let me try this again. This is actually the second time I'm making this video. Okay, so we're talking about classifying matter, and you can see in the picture that we would classify it. Mixtures are broken down into substances, which are broken down into compounds, which are broken down into elements. Alright, so the definition of elements. It says an element is the simplest pure substance. It means that everything inside an element is exactly the same. So all the atoms would be exactly the same for that element. So potassium would have elements. Potassium would have atoms that are all the same for it, and iron would have different atoms that are all the same for it. Symbols were introduced in 1813. This is just a short way for the chemists to write the symbols. When you have to write out your whole experiment and the whole reaction, it's a lot easier than having to write the whole name. Each symbol consists of one or two letters, and the first letter is always capitalized. So if we saw a big C and a little O, we would know that they go together. This is actually cobalt. We know that because the second O is small. If it was a big C and a big O, then this would be carbon and oxygen. It would not be an element, it would be a compound. Okay, these are the commonly used symbols for this class that you should know. That way you don't have to constantly look them up. Try to think of the story we said. You know, AU, give me back my gold watch. I see you, copper. Think of all the things to help you remember. It says some of the symbols are based on the Latin names. That's important. You should know that. Okay, atoms are called the building blocks of matter. All elements are made of atoms. It is the smallest piece of an element that still has the same properties. And atoms can be broken down into subatomic particles. Subatomic means smaller than the atom, and we're talking about protons, neutrons, electrons. It says, why is water a pure substance, but it's not an element? And the reason is, if we were to look inside water, we would see oxygen and 2 hydrogen. Nice drawing. And every single molecule would look the same. Remember, a pure substance is when everything inside it looks the same. Okay, so compounds are also pure substances made of more than one element that are chemically combined. The only way to separate them is through extreme heat, extreme electricity, or both. It says chlorine all by itself is poison. If you've ever smelled chlorine up close, it could even take your breath away. Sodium all by itself bursts into flames when it touches water and can kill humans. What do they form when they bond? They form NaCl, which is table salt. It's important to know that once two elements bond, they lose their original properties and get new ones. Alright, a molecule, the smallest piece of a compound. It's made of 2 or more atoms that are chemically combined. It still has all the same properties. This is like the example we just used with water. So just remember, elements break down into atoms, compounds break down into molecules. Alright, a chemical formula. This tells you the number of atoms for each element. So when we look at H2O, first thing that you want to do is first figure out how many elements do you see. So we have 2 capital letters. We see hydrogen and oxygen. And oxygen doesn't have this little number, the subscript, so we know that it has 1. So you'd go through and put in your 1s first. So altogether there are 3 atoms. Separately, hydrogen has 2, oxygen has 1. Okay, so subscripts are placed to the lower right and give the number of atoms unless there's only 1, and then there is no number written. You need to know at this point that a chemical equation represents a chemical reaction. So in this reaction, it's saying when I mix 2 hydrogen atoms with 2 oxygen atoms. I bond them. After the reaction, I get water. And everyone always says, well, where'd the other oxygen go? We'll get to that later when you learn how to balance equations. For right now, though, know that this arrow does not mean equals. Equals is wrong. It means yields or produces, which means creates. All right, so quickly let's talk about counting atoms. So, if I have, we're going to use hydrogen peroxide, H2O2. You could tell me that there are 2 hydrogen and 2 oxygen. If it's in parentheses though, and there's a number on the outside, this number tells me that in the parentheses I actually have 3 of these. So I now have 2 times 3, which would be 6 hydrogen, 2 times 3, 6 oxygen. Now if a bigger number were put over here, let's first add another element, xenon. Xenon only has 1. This 3 does not affect it because it's not in the parentheses. But if there were a coefficient, a big number, this number says I have 2 of all of this. Okay, and I've already used this 3, so I can get rid of it. So I would say I have 2 times 1, 2 xenon. 2 times 6, I have 12 hydrogen. 2 times 6, I have 12 oxygen. So if it said how many atoms total, I would say 12 plus 12 is 24, plus 2 is 26 atoms total. Okay, we're going to skip this stuff because we're not going to get to this yet. Okay, so let's get over here to classifying it further. We already went over elements, we already went over compounds, so let's talk about mixtures. Mixtures are 2 or more elements or compounds that are physically mixed together. So this is not a chemical bond, they are just physically together. It's not a pure substance, everything in there is not the same, and it can be separated easily. Classifying matter. You need to know that the word classifying just means grouping, separating, organizing by something. As far as matter goes, they group it by what it's made of. Okay, so a mixture consists of 2 or more substances mixed together physically. Your example is salt water. We should be able to separate them easily. The way we separate salt water is we boil out water and the salt is left in the pan. Here are 4 properties of mixtures. They keep their separate identities. Salt remains salt, doesn't change. They can change physical properties. That solid piece of salt had dissolved and became liquid salt. It can be any amount, it doesn't have to be specific, and it can be separated by simple means, which means easily. So how do we separate these things? Coffee with sugar in it, you would boil out the coffee. Iron and sulfur, you would get a magnet and pull all the iron out. Raisin bran, you would simply pick out the raisins. Okay, so mixtures are classified or organized or grouped on how well mixed they are. Some of them are not mixed well at all, and some of them are very well mixed. So the 2 main types, heterogeneous is least mixed. It's like this example here where you can see all the pieces. Examples would be salad, raisin bran, trail mix, where you could just look at it and see there's a bunch of different things. Homogeneous looks like it's all one thing. It's very hard to tell that it's a mixture. The stainless steel all looks the same. Okay, homogeneous mixtures, there are 2 types. A colloid is the first type. The particles are mixed but not dissolved. They do not settle out upon standing. It stays mixed. Cloudy gives it away. Think of colloids as cloudy. Milk, toothpaste, paint, fog, shaving cream, those are all colloids. Remember in this video demonstration, he showed that the light, when you shine through a colloid, makes a beam of light that travels through. It doesn't just scatter. Okay, a solution is the best mixed. This is where something has been dissolved. It is equally dissolved throughout the drink. It's not as if you took your first sip of Kool-Aid and it's really sweet and then the rest of it isn't. It would all taste the same. Anything where something's been dissolved is a solution. Kool-Aid, ocean water, air, believe it or not. Those are all solutions. An alloy is a type of solution. It's a metal solution where two metals have been melted and dissolved into each other. So brass would be your example. It says brass is copper and lead. Which type of mixture would each of these be? Milk would be a colloid. It doesn't settle out and it's cloudy. Raisin bran would be heterogeneous because I can see the raisins in the bran. Coffee with sugar in it, the sugar's dissolved, it's a solution. Salad, it would be heterogeneous. Air, I could say homogeneous, or I could say a solution because something has been dissolved. Okay, the last thing we're going to go over is some vocabulary. The word soluble means that it can be dissolved. Things that are soluble, sugar, salt, any kind of mix like hot chocolate mix. Insoluble means it cannot be dissolved. Oil cannot be dissolved. You can heat it up, you can stir it, you can do anything you want, it will not be dissolved. A solute is what is being dissolved, and a solvent is what's doing the dissolving. Remember that the universal solvent is water, meaning it can dissolve just about anything. And so here's an example to try. Salt water. What would the solute be? What's being dissolved? The salt. What would the solvent be? What's doing the dissolving? The water. Okay, just listen to this as many times as you can. I'm sorry it didn't make it on there the first time.